Good morning, Valley Middle School STEM. Welcome to the second rotation of STEMsday activities in the On the Moon series. Today's activity is called Heavy Lifting. We'd like to thank the Society of American Military Engineers for sponsoring today's event. Let's take a look at your challenge. Today, your group will be asked to construct a crane that can be used to load large moon rocks. More specifically, we're asking your group to build a simple crane capable of lifting a river rock. Before we dive into the challenge too much, let's take a look at the anatomy of a crane. A crane will have some sort of a chassis or a base. It's going to have a boom or an arm that extends from that, and you're going to need some sort of a cable. In your case, it'll be string for the take-up reel and the pulley to work. So you're going to need a take-up reel, you'll need a pulley out here in the end, and you need some sort of a scoop basket or hoop as well. Here are the materials you'll have to build your crane. You will have a cardboard box blank, which you can fold into a cardboard box, your moon rock or river rock, of course, a sheet of cardboard, scissors, tape, a cup, a paper clip, a couple of pencils, a ruler. You will have string and straws. You will also be working under some parameters and constraints. Students may only use the materials provided in the bag. The crane must be able to lift a rock 2 inches off the ground, and your crane must have the following components: an arm, a pulley, and a take-up reel. I think time will once again be the hugest constraint that you need to work under. You're going to need to get through the imagine and design phase very quickly and into building so that you can test and evaluate your crane. We should be in pretty good shape here because I looked at some Valley Middle School childhood pictures of the teachers, and we have a lot of experienced people working with cranes. Hey, don't forget your hard hats, kids. Here's the way the morning will roll out. We'll get into the imagine design phase here at 7:50 and then test evaluate for about 25 minutes. We'll be cleaning up at 8:15, wrap up at 8:20. Homeroom will be dismissed today at 8:25. As you work through the collaborative design process, reflect upon these questions. How will you keep the crane's arm from breaking off the box as it lifts a heavy load? How will you stop a heavy load from pulling the arm to the left or to the right? How will you wind and unwind the cable so that the hook or basket can go up and down? Early finishers? How about designing a handle for your crane's take-up reel? Can you reduce the workload by adding a second pulley? What's the weakest portion of your crane? How could you strengthen that part? All right, cleanup today is pretty straightforward. Put the tape, scissors, ruler, and river rock back in the plastic bag. Throw everything else away or take it home. Make sure to leave time for the all-important wrap-up discussion. Teachers, there are great curriculum connections and questions in your lesson plan. Today we'd like to end our STEMsday video with a little moon trivia. Did you know that the moon is 1/4 the size of the Earth? And that weight is a measure of the gravitational pull between two objects. Therefore, the moon's gravity is 1/6 of the Earth, and thus things weigh less on the moon. Which poses an interesting question. How much would a 120-pound Valley Middle School of STEM student weigh on the moon? Well, to answer this question, I tracked down moon and math expert Mr. McNeil on his ranch this weekend, and he said that the moon and math go together like cowboys and vittles. I'm not even sure what that means, but anyway, he said you set up a ratio proportion box. You know, if it's a 1/6 of the gravity, that means that on the moon, something that weighs 1 pound would weigh 6 pounds on Earth, or a 6-pound object on Earth would weigh 1 pound on the moon. So if you put it in a proportional box, 120 pounds on Earth, and you multiply that diagonally, and then you divide by 6, you would have 20 pounds. Makes sense. Interestingly enough, Mr. McNeil also said that astronauts are often up to 2 inches taller in space. As a matter of fact, he even claims that if he were to have gone to school on the moon, he could have played in the NBA. I'm not so sure 2 inches is going to make much of a difference there, but it's kind of fun to think about. Thanks for participating in today's STEMsday activity. You have a great day.